Well, good evening, everybody. So it's a little bit of a late night recording tonight. Lots going on in this last week and even today. And as you can see what I've got on the bench here, we've got the EG4 Chargeverter. So we're going to take a look at that, see how we can put it to some good use in our environment. So let's get started. So this is one of many little toys that I've gotten in the last week or so. This is the only one that I can talk about right now. For a lot of you that have been in the solar arena for a little while, you probably look at this and you're like, yeah, this is old. You're just now getting one of these? Yeah, I've been debating on picking one of these up for quite some time and just never really pulled the trigger. I knew that it was probably something I was going to use, but I don't know, I just kind of dragged my feet. But I'm not really planning on using this the way it's designed for, at least not the way that it's advertised for. So it's advertised as a way to hook into a generator to be able to clean up the power, to directly convert the AC from the generator to the DC going straight into your batteries, bypassing the need for your inverters to have some kind of a built-in charger. So the Victron inverters that I have no need of this because they're designed to handle whatever incoming power you give them within their specifications. Maybe down the road I'll have something else that might need this. But for now, the Victrons don't. So I plan on using this as more of a regular charger or even a dump load for testing the output of other devices so that I can use this to dial in the specific output and not waste the power and dump it into my main house battery. But this is designed to take in 120 or 240. I believe it's up to 26 amps AC, and then it can output up to 100 amps DC at 48 volt nominal. If you set this up in a 120 volt configuration, you'll only get the 50 amp output. You have to have a 240 in order to get the full 100 amp output of this. And and looking at this, it's a giant brick. I mean, you got your beefy 240 plug, and then you've got your DC connections with lugs on the end. Nice 3 foot long AC input, and maybe, I don't know, 6 foot long on the DC side. Built-in 125 amp circuit breaker, and then you can dial up and down the DC current and also program in the DC voltage for when you want this to stop charging. I picked this up from Current Connected. I looked on their site and they had, I believe, 16 or 17 in stock. So I ordered one. I believe I ordered it at like $11.50. At 12 o'clock, I got a tracking number. I don't even think I get a tracking number that fast from Amazon. And then by 6 o'clock that night, I believe I had an email from FedEx saying that they had received my package, and then it should be delivered in 4 days maybe. And then I had it in that 4-day time frame. So very, very fast turnaround. My hats are off to the folks at Current Connected for that fast turnaround time. As I said before, this can handle 120 or 240 volts. But if you want it to run 120, you need to kind of modify this plug on the end, because the way this is wired up, it doesn't actually use, from what I understand to be, the standard pinout. So let me see if I remember here. So you've got your curved pin, which is your ground, and then you've got, in this configuration, you've got a hot here and a hot here. And then I believe, usually in a 120 configuration, you've got your ground, your hot, and then your neutral is over here, directly across from the ground. So that means that you can't just go buy any adapter from Amazon, plug it in, and expect it to work. You either have to rewire this the way that the adapters expect it to be, or you have to do what I did, and I made my own adapters using the configuration that was already in the Chargeverter cable. So I just had to rewire things, and I added a 30 amp 120 plug and then a standard 15 amp plug, so that I can use this as basically a dump load on a lot of different 120 volt devices or a 240 volt device. I know when this first came out, I believe they had some quality problems with the builds, to where sometimes the modules on the inside became unseated. You could not get your full 240 volt output unless you reseated the modules properly. And I know I have seen a few updates on these in the past, but I just want to see if they still have the same setup or not. And if nothing else, I did notice that this cable here is loose. So while I've got it open, I can just tighten that up. They've got little dabs of glue to hold the modules in. You see our AC line coming in, and it drops underneath the circuit breaker and comes over to probably a board that we can't see down in the middle, or it probably comes right here. Then we've got our DC lines. The positive line is being broken. Our negative line is down underneath at the bottom. I mean, it's a very basic charger. Each module that you see here handles half of the current. Looks pretty good to me. The connections here, nice and snug. Yeah. These glands, I mean, they're hard to just tighten down. So I'll have to get this gland on this side tightened down before I close everything back up. So this might be a good investment for some of you that have kind of the cheaper all-in-one inverters, you know, the 6000 EX, the 6500 EX, maybe a Grow Watt 5K. They might not be able to handle dirty generator power. So if you don't have an inverter generator, you just have, you know, an open frame style generator that the frequency can be bouncing all over the place. It might output dirty power. This is designed to help clean that up for you. But as I said earlier, that's not my plan for this right now. I might end up using it at some point for that. But right now, I want to get this thing wired into my Lynx Distributor, so then I can start using it as a dump load for some of my other tests. So my distributor has 425 amp fuses already. I actually moved my MPPT 15035 off of this last mega fuse because that only needs a 40 amp fuse, and I was using this 125. So I have an inline A&L 40 amp fuse, and I'm using these two posts here. So we'll go through and add our Chargeverter onto this last set here. Alright, so we've got our Chargeverter all wired up into our bus bar system, which is going to be awesome. Here's what we'll do right here. We've got our Anker Solix C1000 portable power station, and then our Chargeverter is all wired in. I'm going to take my standard 120 adapter that I made and connect it in to the Chargeverter plug. Turn on the Anker Solix, so it's at 77%. And then we'll plug it into this end one and turn on the AC. So when you turn the Chargeverter on, that fan starts to ramp up a little bit, and then it eventually slows down. Look at the display. I just have some random voltage set here to charge to, 56.5 right now. Hit enter and you can change your voltage. And then you can also change your current. So I could change my current to anything up to potentially with 120 volts, up to 50 amps. It'll let you do up to 100, but you're only going to get the 50 if you're only on 120 volts. And then remember, the current rating here is DC. So let's just set it to 5 amps for right now, and escape, and flip a breaker. So 5 amps at 52.5 volts. You see the charge light over here blinking, and we're discharging 317 watts over here right now. And we look at what's going in, 272 watts going into the battery. And then to turn it off, turn off the circuit breaker and turn off our AC output. So a nice fun little toy that'll be able to be used for quite a lot of different projects, but I can't tell you what they are right now. You'll see them eventually. But with that, I'm gonna let y'all go. So y'all stay safe, stay warm, have a Merry Christmas, and we'll catch up with you later.